Good morning. I am Lindy Knowles. I think I need to share my video, sorry. I'm a senior science officer at the Bahamas National Trust. I'm glad to be presenting today on a very small but highly focused restoration project within the Bahamas. Given that there is a regional collective of people in the room, first, can you see my screen, I should say? Okay, I'll take that as yes. So the Bahamas is found just outside of the Caribbean Sea and what we like to call the Lucayan Sea. We're a small island nation with about 400,000 people scattered throughout the archipelago, though 80% of that population lives on one island. We're a very low-lying area. Highest elevation is 63 meters, and I think it's about 90% of the population lives with less than 1 meter above sea level, so very vulnerable to climate change. We have lots of mangroves. So on the east coast of our islands are primarily hilly and rocky, and on the western side, on the leeward side of the islands, are very flat. Now, when I speak about it, we have had loss of mangroves taking place for centuries and picked up really in the last 100 years, primarily for access to the sea, for farmlands, and for development. We not until recently viewed mangroves as a wasteland. And so, for example, on the island of New Providence, where I live and predominantly work, and where 80% of the population lives, we've lost over 37% of our mangroves in the last 50 years. And even though it's 30% loss, that's total loss, we haven't accounted really for how much has been fragmented and degraded over time as people filled in the land to make housing developments or to dig it out to make marinas. And when we're speaking about it, we're only looking at the coastal loss in this statistic, because the interior wetlands have also been lost at a higher rate than the coastal ones. I work at the Bahamas National Trust, and going back to what I say, it's a very specific project we're working on. I don't represent the work that's taking place on the other islands, which are massive and are the result of a very acute destruction that took place in 2019 from Hurricane Dorian. I have a colleague that's going to present later this afternoon. Though she's speaking about the community aspects of her restoration, it's still a very important restoration project that's taking place. So my organization protects about 2.2 million acres of land and sea in the Bahamas. And I think that works out to be about 1 million hectares or 800,000 hectares. And of that, half of it pretty much is wetland areas. And our job is to take areas that have been degraded and restore them to a more pristine environment, as well as making sure that the areas that are still in a good environment are protected so that we can sustain the fishing that takes place throughout the archipelago, as a number of our commercially important species spend their early part of their lives in the mangroves. I'm speaking of the spiny lobster, the queen conch, and finfish. Now, the park that I'm speaking on, once again, is a very small park. It's only 500 hectares. It's a coastal wetland system found on the southern side of the island of New Providence. And even within this area, the restoration sites combined are less than 1 hectare of space. But this area, being on the capital city and the capital island, is very threatened by the development that goes around it. So we have urban and agricultural lands that surround us, and a lot of the agricultural lands are being converted into housing developments as the race for space heats up for the land. So, sorry, before I go, the Bonefish Pond National Park is the last intact mangrove ecosystem on the island. There are other areas that remain, but those have been sliced and diced in preparation for developments, and the developments just failed at that point and money ran out. So we have 2 particular sites within the Bonefish Pond National Park. Both are about a half hectare apiece. Both are pretty much identical in their destruction, I guess. Both were used as dump sites. Both were used as burning sites for illegally harvested copper when people were stealing from the electrical lines. We had to use heavy equipment in the cleanup process to start us from scratch. Both had a lot of community support. The one main difference is that one, the destruction was very acute, where somebody brought in an excavator determined to build themselves access to a dock for their house. And the other was a degradation over a period of 40 years. So site A, which is on further east, was really the destruction took place on the course of maybe a year or so, where it was degraded massively, as well as that's the site that we only did restoration in 2012 and monitoring the natural progression of that site back to a more pristine environment. And site B has been a free-for-all site where wherever we get some mangroves, we plant them out and just really looking at the overall change of the system. Combined, we had a 30-year plan for restoring these areas, and we're on year 12. But I will say that within this 30-year plan, it was very abstract 30 years. We don't have a proper plan in place for the restoration of the area. And so site A was heavily detailed, and honestly, truly, timing was bad. But I'm going in the field to collect the final data set for site A tomorrow before we start replanting any gaps that natural recruitment didn't take place based upon how we modified the hydrology to try to get water to flow through the area after it had been blocked off. So given more background, as I said, it was degraded. The person had filled in the hydrology to stop the water flow because the current that passes through the area gets to be about a 1 knot current on a good day. In the background of the picture here, I don't know if you can see my mouse, but there's a rectangular structure, which was the guy using the outline of a septic system as whatever materials he had available to block off the water flow. In the bottom left, you could see where a lot of copper was burnt, but never utilized or sold. So we stopped that. We got about 700 mangroves from the site, donated by a local resort, and we put together, I think it was 10 square meter plots with different planting densities. Some were left untouched for natural recruitment to take place because the prevailing research at the time said it's always good to just reconnect hydrology and let nature recover. But for those who live in small island nations that don't have a lot of nutrient, fresh water, and good soil, natural recruitment is very sporadic. And so we do have to supplement the mangrove plantings in areas. Otherwise, would take 5-6 years in countries with rivers and nutrients. Will take us 100 years to restore an area. So we need, for where they need a little help, we provide a little bit of help. We also did assessments of the marine systems, looking at the water quality, looking at the fish community structure, as well as looking at the benthic structure. And I could say in that area, visibility was less than 1 meter. And immediately after restoring the hydrology, the visibility went up to what is generally accepted for the mangroves in the Bahamas, which is like a 10 to 12 meter visibility. The initial project was from 2012 to 2017, and last year should have been the final data collection to see what a 10-year regrowth of the site is, but we haven't been able to go back as yet, which we'll be doing this week. So we just took some heavy equipment, took some people, and we planted mangroves. And we were fortunate at the time that there was a summer camp that were looking for activities for their kids to do in the environment. And we took them in. We had propagules and we had seedlings, and we planted them. And for our site, we realized that there wasn't much difference in the growth rate after 2 years between our seedlings and our propagules because of how slow everything tends to grow in the site. So you can see here, me and my colleagues measuring the growth rates over that particular time and looking at the survivorship, which you can see in this following graph here, which is just very basic graphs showing the survival rate. We lucked out in that some of our plants, our methodologies had about 100% survival rate. The others had an initial die-off of about 50%, but then after that, there was minimal death within the 5-year period. We even tried some from our inland wetlands, which are much closer to being freshwater than they are to being brackish. and those pretty much did not accept the transplant and died almost immediately. But the ones that did survive, and I say the 3 that did survive, seemingly have, as last time I was there, survived. So then we had a second site, and this used to be a boat ramp for people to launch boats from, but we have an unfortunate bad habit of people not wanting to take things to the landfill, so they just dump it in whatever's available and quick to access. And so when we inherited the site in 2002, but we weren't able to do any work till 2009. And so 2009, we just hit the ground running, and we removed, I think, 30 tons of trash in the first activity. And then we used the same heavy equipment that you see in the image on top to basically just push everything to the bare rock. And so you can see the top picture here is what the site looked like in 2010, I'm going to say. And the bottom was a bit like 2011, where we didn't see any real growth. So around 2012, we inserted these telephone pole stumps to restrict access so that we could begin planting in the area. And this was as of 2019 here, where we planted probably about 100 red mangroves a year for 7 years. So about 800, 900 red mangroves to the site. And of course, we in 2017 decided that, we wanted to try some black mangroves. But the black mangroves we planted, we clearly didn't know which sites were ideal for black mangroves. And so they haven't grown very much. The black mangroves that naturally recruited are doing much better than these ones. So as I get further down, I'll speak about wanting to add more black mangroves, but have a better understanding of the environment. And so, like I say, we've used this area to bring in community members to plant mangroves. So the picture on the left is that we try at this point to utilize the mangroves from within the park, because it is a productive mangrove system, to keep using the propagules and the seedlings within the park so that we don't take them elsewhere, have to spend additional money that we may not have, because for this one, we don't have a specific project. We depend upon the donations of resorts and whatever we have available in-house to plant the mangroves, which was mentioned before as, wanting to make sure that you survive longer than the funding. And so the top one, we have a diplomatic day where all the diplomatic corps present in the Bahamas came and planted. The bottom lady was a student who's doing an Eagle Scout Award, and she brought in a bunch of friends from the Bahamas as well as abroad to plant mangroves in the area. And so lessons learned, we need more diversity in our plantings, because as much red mangroves as we planted, the black mangroves that naturally recruit are doing much better, I would say. And so it's not just the red, black, we also have some white mangroves that have started to come into the area. And so as they're now coming into seeds in the Bahamas, we're going to slowly add those into the system, as well as put some in a nursery. We want to increase capacity of the team. So for a number of years, I was the main person leading this operation, but we've started to add new staff to support the work. And we've been able to benefit from some of the training that was funded, I think, by the Caribbean Development Fund through the Mangrove Mania and Bonefish Tarpon and Trust. We've also been able to utilize connections we have in the region to get access to planting mangroves in nurseries and to get them to grow a bit better from Camilo Trench, I think is immediately after me. And then next steps we have, I'm going into the field for the next 3 days to do assessments of the restoration area to see how things have progressed since the last time we surveyed in 2017, and look at where we could add new areas that haven't been able to naturally recover. And then we're gonna utilize the technology a bit better, because we have access to drones and we have access to the software needed to look at the minor topography changes on the site, adjust the salinity as we would have learned in our capacity thing, to make sure that we are able to put the appropriate plants where they are. And we really want to diversify our planting. So instead of it being 95% red mangroves, we want to drop that down to about 50%, 50%, 40% black mangroves and about 10% white mangroves, so that within the next 20 years we can finish off this project and you will never know that it was a dump site. With that, I say thank you, and I guess I'll wait to the end for any questions.